Okay, welcome back. In the last video we looked at constructions, particularly opaque constructions and zone attributes. In this one we're going to look at transparent constructions. To do this, it works the same way as with our opaque constructions. You can take a construction out of here, and this time we're going to define a window instead of an opaque material. So this is a very simple material, the bare basics of what you would need, and in this case we're just going to set one layer. So I'm going to take this and move it down to 1 and just plug that in, and then I'm going to make this let's just make this a Loisos window. And I'm going to plug that in for the name and add the construction to here. The material itself is, again, actually I'm going to use the same name, Loisos window. It can have the same name. And then for the U value, this is all in SI. And so U value, sorry, my SI U values I don't know offhand. So I'm going to plug the name of the material into the name, and then for the U value, remember this is in SI units, watts per meter Kelvin. And let's do a very good assembly. This includes the frame, by the way, so this is both the frame and the glass. So maybe like 1.3 watts per meter Kelvin for the U value. That would be a really good thermally broken frame and a very good double glazing with a Loisos film. And then a solar heat gain coefficient of maybe 0.3 and a visible transmittance. Let's do like a Loisos 3 coating would be, say, 0.64. So that's my material, and I think in this case it should add, yeah, it all added to the library just fine. There. So now I can plug in my Loisos window to. I can define that as a window construction there, and hopefully my window changes name. Now right now it's set to wall 01. To change that, actually, do I have the windows on? Yes, I do. Aha. So it's seeing the wall, and instead I would like to see the window. In order to do that, I think we need to plug in a boolean here, and you can see the windows. It looks like these windows, the surface normals, are backwards, which is why this is reading backwards. Now you can see it from the other side, Loisos window. But I don't think that matters. This seems to run okay with it backwards, just like that. Where it will matter, I think, is when you go to insert blinds or shades or something like that, and we can talk about that when we get to it. Okay, so I'm going to take a second here, pause the video. I'm going to clean up this mess that we've created here into something a little bit more manageable. Okay, we're back. I've cleaned things up and organized all the envelope geometry and material assignments here. And over here, I've just put off to the side those material definitions and constructions, kind of created my own library. So I'm realizing now that a lot of what I'm showing here, this was not the intent, but it seems to overlap quite a bit with what Chris Mackey has already recorded. And so rather than duplicating that, what I want to do is, in the spirit of the Honeybee Quickstart, which is how I started this, is to run through, literally, very quickly, all of these other different components to the HB zone. And it all uses the same logic of feeding the HB zone through a component, altering it, and bringing out the other side. So we've already discussed geometry of materials, which is probably the most time-consuming part. And I'm going to try to zoom through these others without spending a whole lot of time explaining each thing. For a program, which defines the schedules and internal loads for the most part, and to some degree even the default constructions, you can adjust the program by going to this number 5 and pulling down Honeybee building programs and the list zone programs, and then taking out that Honeybee item selector that, oops, wrong one, item selector that we showed you before, and then plugging them all together. I like doing it like this so it conserves a little space. And the building program, you can choose from these prepackaged building programs. Say, let's look at a secondary school, and within the secondary school there's multiple zone programs. So if we're talking about a classroom, we can select there. And now this, if we plug this into our zone, like now if we take this and plug it into our zone program, back up here, we can change the zone program from what was the default open office to now classroom, secondary school. And we'll see how that impacts some other things in a second. Next one, internal mass. Very quickly, this is a way of defining what thermal mass is in the zone for any wall or surface or furniture that doesn't appear in the envelope. And this is a pretty simple, self-explanatory component. Honeybee add internal mass to zone, and we can run the zone right through there and then out the other side like so, and we give it a name, like let's call it concrete wall. Say this is a concrete wall in the middle of our zone, and then we can either put in the surface area in meters, square meters, like 10 square meters, or you can actually assign it a geometry. In this case, just for expedience, I'm going to put 10 square meters in there, and then you can assign it a construction. So let's take the same wall 01 construction that we used before, but you can add any construction that you want. It says input for surface is invalid. Surface or surface area, this takes a BREP that you can define as the surface. This BREP has to be entirely inside the zone, so we can make a mass layer here as just copy our make a corner vertical. Assign that to the mass, and then it needs to be a little bit smaller than the zone and entirely inside. So that's our mass, and actually just go ahead and assign it there. And then we also need a construction. In this case, let's use the same construction that we used before for our walls. And voila, we have a thermal mass interior construction, and it automatically reads the area of that. Okay, so zooming right along here, that's internal mass. I'm going to group those together, and then let's move on to internal loads. You can find the internal loads here at 08 set energy plus zone loads there. And again, I'm going to run the HB zones right through there and connect this. Take this out of this group. And you can see what the default loads are here by hooking up a panel to the loads. This reports out what's been assumed, and you'll see if we change the, let's do this. I'm going to copy this. You can see if we change the zone program to, say, the library auditorium, then the loads will also change. You see the equipment loads went from 3.6 watts per square meter to 7.3 watts per square meter. And all of these different inputs have changed. So that's a handy way of just seeing what the defaults are, and then to override them, you can come in and hook up any number. So instead of, say, 3.6 watts per square meter, I can do this at 2 watts per square meter for the equipment load, and it overrides it, and you can see that right there. So as you're doing your energy modeling, you can use either a real number from a real space if you're trying to model a real space, or you can use the defaults, or you can use guidelines like ASHRAE 90.1 and ASHRAE 62 give both code required or minimum requirements for some of these numbers. So let's move on to schedules, because now that we've got now that we've got loads, we need to know when those are on and when they're off. This is just telling us what they are. And so that's the next part, is schedules. And again, go to 08, set energy plus zone schedules, and drop that in, attach the zones, and we can move here and see how these schedules are defined. In this case, it's a little bit more difficult to get at the underlying data, because what this does is it assigns a name to each schedule. So the occupancy schedules are secondary school auditorium occupancy, or OC. To find out what that actual schedule is, you can come in here and decompose the energy plus schedule and feed a name in, like secondary school auditorium OC. You need to spell it correctly, and out of this should feed the name, the schedule, and the comments, which will tell you a little bit more about what that schedule means, the format of it. So let's get these the right size. This is telling you that the schedule goes from January 1st to January 3rd, and then January 4th to June 27th, and then June 28th to July 4th, July 5th to August 29th, etc., through the year, starting in January and ending on December 31st. That makes up the whole schedule. This does not tell you what the what you really critically need to know, which is the fraction that is being changed here at each of these scheduling points. Unfortunately, there's not a great way of doing that natively in Honeybee, and I'm hoping that there will be sometime. The best way right now is to go to this Honeybee Convert Energy Plus Schedules to Values, connect in the schedule name, and then out of this is going to come the entire 8,760 list of values for that schedule. And this is showing, here's the 8,760. but this is showing the fraction of occupancy that is being scheduled here. So you can see from midnight to 1, 2, 3, 4, 5, 6, 7. From midnight to 7, there's no occupancy. And then from 8 o'clock, 9, 10, 11, 12, 13, 14, till 2 o'clock is 0.25, so 25% of the maximum number of people are there. And from 3 o'clock and 4 o'clock, 95% of people are in there, so I guess an afternoon assembly or something. And then after 5 o'clock, it goes to 10%, and then at night, in the evening, it's down to 0 again. So that's the best way, unfortunately, the only way of looking at these. And of course, as you see here, it changes, so that's January 1st to 3rd, and then January 4th to June 27th. You can scroll down and try to find those dates. Again, kind of a suboptimal way of visualizing this. You could also graph those values, and which might be a little bit more useful, putting them into our 3D graph in Ladybug, and then zooming out to see them. So this is for the whole year. Yeah, this is probably a better way of looking at it. And you can see the occupancy patterns. Again, there's that 3 to 4 o'clock assembly that seems to be happening. And you can see also in the summertime that it's largely unoccupied. There seems to be a few people in there during the summer, just the janitors. So, and here's the scale on all the way on the right-hand side. By the way, this is probably a good time to show you that the default here creates this very long, skinny graph, but if you want to change this, maybe 0.2 is a good value for the x-axis. We'll squish it all together so it's a little bit more manageable to see all at one time. So that's, in a nutshell, internal loads and schedules. I should point out that you can do customized schedules by setting any list of 8,760 numbers, which will act on these loads as fractional percentages. That is a little bit more involved, so I'm not going to cover it here. In the next video, we will talk about natural ventilation and HVAC systems. So I will see you over on the other side.